Virtualization is the process of hosting applications, operating systems, and even entire devices within another device. So multiple instances can be hosted within a single server. And this is how cloud service providers make a profit. They purchase very expensive hardware, and then they segregate that hardware into different pieces using virtualization, and then they sell those pieces to different cloud customers. There's other different ways that cloud service providers can make money. They don't always have to use those virtualization techniques, but virtualization is a huge part of cloud computing, and it's one of the main money makers. For example, data storage segments are created using a technology using virtualization. So instead of having a hard drive or a series of hard drives and then selling maybe one hard drive per customer, the cloud service provider will have a series of hard drives controlled by data controllers, and then they'll segment those using a form of virtualization so that individuals only have the storage capacity that they require. So virtual machines are machines or operating systems or devices, it can be entire computers, that are managed by a hypervisor and created to create virtual instances. So one good example is VMware. And if we look at VMware, we have, right now, I have a Kali Linux operating system. Okay? So this VMware is a form of a software hypervisor. Okay? So right now I have a Linux device running within my Windows device. So if I log on, I can access the internet, I can do all sorts of things using this virtual machine. Okay, and that's well, I have to activate the Wi-Fi, but this machine is contained within my Windows machine. It's allocated its own set of storage, it's allocated its own resources, so I can run programs, etc. And we use this, I use this Kali Linux operating system to run different demonstrations within the course, particularly on how attackers perform attacks on, perform their attacks against the systems that you're attempting to secure, okay, or perform attacks on cloud systems. We'll get into this when we talk about the OWASP Top 10 and application attacks, but this is an example of a software hypervisor or a Type 2 hypervisor. We'll talk about the difference between hypervisors later in the course. So virtualization allows for the creation of these operating systems, these devices, using existing hardware. And since you can create multiple instances using a single device, that introduces some additional risks. So you have what's known as a multi-tenant environment, where you have one piece of hardware, say one server, hosting multiple customers. So all of those customers' data are stored on that server, okay, that's being processed by the same server. You can have some risk associated with that, okay? Guest escape is when one of those customers is able to manipulate data either intentionally or unintentionally through maybe a data leak outside of their instance. This usually involves attack on the hypervisor, like attack on the VMware itself. VM sprawl can occur when you have multiple or unused VMs on a network. So this is more of a concern for a private cloud, where an organization has created VMs or virtual machines for themselves, and they lose track of these virtual machines. They have virtual machines that are just eating up system resources, eating up storage space, but not actually being actively utilized. It's just like having a physical network and losing track of some of the devices on your network itself. Those devices don't get patched regularly, or if they get patched at all, and they present a vulnerability in your network. An attacker can exploit those more easily because they're not being patched and not being paid attention to. Same thing with VMs. Well, with VM sprawl, it's mostly eating up system resources, eating up storage space that could be allocated to other VMs. A software-defined network is a form of virtualization used to route network traffic rather than using a physical device or a piece of hardware, such as a router or a switch. So the software-defined network would create a virtual network or be used to route network traffic within a cloud environment. So the software-defined network works by separating the data and the control planes. If you know basic architecture, the data plane contains rules on how to forward and block traffic, while the control plane contains rules on which path the data should take. Okay? We'll talk about planes a little later in the course. So instead of access control lists, software-defined networks use attribute-based access control, or ABAC models. Attribute-based access control, as a refresher, is a form of access control that uses attributes that can be defined by the organization. So you can create attributes for a user, maybe based on years of experience or their job title or their name, or maybe you can even do something like hair color if you want, or favorite color. Any of those things can be attributes. You can place a bunch of different attributes together to describe something in a plain text sentence almost. And that's just the way the logic works within ABAC, or attribute-based access control. When it comes to storage, the ability for organizations to store and access data regardless of physical location is one of the main draws of cloud computing. It's one of the reasons why cloud computing is so often used as business continuity or disaster recovery solutions. An organization might be physically located in an area that's prone to flooding or a hurricane. Say they live in Florida and they're concerned about hurricanes. They can store a backup copy of their data in a data center in maybe Washington State. Then they don't have to worry about hurricanes anymore. So if a hurricane knocks out their primary place of business, they have a backup that won't be affected by that same environmental disaster. It also helps organizations who are geographically dispersed. Particularly in today's environment, you find many workers geographically dispersed, and an organization may seek to, instead of having a physical location, a physical office, opt to store most of their information on the cloud, maybe even run their desktops, run their company devices through a cloud-based operating system. So workers would just log in using any device to a virtual desktop instead of the organization having to issue laptops to every individual. Having storage geographically isolated from an organization or in a separate geographic location can present legal and regulatory challenges. An organization needs to be very careful about where they store their data, and they must understand where the CSP stores their data. Otherwise, they may be subjected to additional regulations, additional laws that they weren't intending to be initially. Some countries might have different laws regarding data storage and privacy, particularly within the European Union and the General Data Protection Regulation, GDPR. So if an organization is opting for a cloud service provider that maintains their cloud storage in Europe, that organization may be all of a sudden subjected to additional regulations or additional laws that they weren't intending to. So that needs to be a consideration when purchasing cloud services. And selling storage space, simple data storage on the cloud, is one of the most common cloud ventures out there. So many data centers are focused primarily on cloud storage, and they'll segment their storage to offer pieces of that storage to many different customers, and customers will purchase only the storage they need at any given time. To provide these services, these cloud services, cloud service providers rely on a network infrastructure. Networking is critical to cloud computing, and that's how organizations, how their customers for CSPs will be able to access those cloud services in the first place. So network technologies and network security have to be foremost in a CSP's mind when offering cloud services. That includes security and redundancy making sure that networks are maintained and operating on a continuous basis, ensuring the availability, the confidentiality, and the integrity of data, not only at rest but in motion, and creating an environment where the availability of the data is protected through redundancy, through server clusters, through power backups, power generators, uninterrupted power supplies. All of those need to be considered by the cloud service provider. Network protocols and network encryption needs to be implemented to protect customer data and also protect the reputation of the cloud service provider. You can't have a cloud service provider that has their data or the data they exchange with the customer leaked or intercepted by an attacker, will suffer a major reputation hit and may face legal penalties. Databases are critical to storing a lot of the information on a cloud. Some cloud services are structured around databases and providing virtual databases for organizations. And with databases, data is stored and organized according to its characteristics using many different types of database storage strategies. So databases are used oftentimes by cloud source CSPs to enable cloud customers to access the correct data. So a cloud customer might access their CSP through maybe a web interface that would reference a database to authenticate that user, to ensure that they're authenticated to the correct cloud resource so that they get access to their data. So relying on databases and database security is very critical for a CSP as well. And orchestration is where you use a set of technologies, set of tools and software to manage and coordinate all of these network connections and interactions within a cloud environment. So orchestration can be performed through automation, and there's many different tools out there cloud service providers can use to provide this, to ensure that their network is operating correctly so they can provide the right services to their customers. Cloud orchestration is also important for a cloud customer because it can ensure that the customer's purchased cloud services are all working in concordance, they're all working together to serve the customer. And a cloud customer that has purchased cloud services from multiple different vendors and maybe has an extension, they purchase those services as an extension to their own network, they may need to implement orchestration tools to ensure that their network is running correctly. So that wraps up our building block technologies. We're going to talk about each of these in more detail throughout the course. Thanks again. See you next time.